All right, let's dive right in. We're going to get to the bottom of a question that every Flutter developer has. What actually happens when you call setState and your UI updates? We're going to crack the code on how Flutter builds and rebuilds your UI. So let's get started.
You know the drill. You call setState and poof, the UI changes. It feels instantaneous, almost like magic. But what if I told you that simple, seamless update is actually a really, really clever illusion? Today, we're going to peek behind the curtain and see how the trick is done. So let's talk about that illusion. There's what you see and what you write as a developer, which is designed to be super simple. And then there's what Flutter is doing under the hood, which is this incredibly sophisticated, high-performance dance. It's time to pull back that curtain. So where does the magic come from? Well, it all comes down to Flutter's core architecture. And here's the secret. It's not one tree that manages your UI. It's three. Honestly, if you're going to understand Flutter internals, this is the absolute most important concept to get your head around. And here they are, the big three: the widget tree, the element tree, and the render object tree. Now, the best way to think about this is with an analogy. Think of widgets as your cheap, disposable blueprints. The elements, they're the long-lived, persistent construction managers on the job site. And the render objects, that's the actual physical building, which is really expensive to change once it's built. Let's start with the widget tree. Now, this is a huge thing to get right. Widgets are not your UI. They're just descriptions, configurations. They're simple Dart objects that say what the UI should look like. And because they're so cheap and lightweight, Flutter just throws them away and recreates them all the time. It's no big deal.
Okay, now for the element tree. And honestly, this is the real star of the show. Unlike those disposable widgets, elements are persistent. They stick around. They are the actual living things that hold onto your state objects and manage the widget's entire lifecycle. This persistence is the key to why Flutter doesn't have to rebuild the entire universe from scratch every single time something changes. And finally, we have the render object tree. This is where the rubber meets the road. This is the muscle. These objects do the really heavy, computationally expensive work of figuring out layouts, sizes, positions, and then actually painting the pixels you see on your screen. And because this is so costly, Flutter's entire architecture is designed to avoid touching this tree unless it absolutely has to. All right, so we've met the team, we know the players, now let's follow the journey. Let's trace exactly what happens from the moment you call setState to the pixels actually changing on the device. So here's the flow. First, your widget's build method gets called, and it spits out a brand new tree of those cheap, throwaway widget objects. But, and this is the genius part, Flutter doesn't tear everything down. Instead, it walks along the existing, persistent element tree. Each element looks at the new widget it's just been handed and compares it to the old one. And only if something is different does it then tell its render object, hey, you need to update. And this right here is the core logic. When an element gets a new widget, it basically asks one simple question. Hey, are you the same type of thing I had before? If the answer is yes, say a text widget is replaced with another text widget, it just updates its configuration. Super efficient. But if the type is different, like a text widget is replaced by an icon, then it's time to bring in the wrecking ball. The old element and all its kids get destroyed, and new ones are created from scratch. That's Flutter's diffing algorithm in a nutshell. Okay, so all of this brings us to something we use every single day but maybe don't fully understand. Build context. It can feel like this weird magical thing that you just have to pass around. But once you understand the element tree, build context becomes incredibly simple. Get ready for this, because this is the key that unlocks everything. Build context is not some special magical object. It is literally just a reference to an element. That's it. When you're using context inside a build method, you are holding a reference to your widget's exact position in the element tree. It's not magic, it's just a marker on a map. So think about it. Every time you write theme.ofContext or context read block, what are you really doing? You're just telling that element, hey, from where you are on the map, start walking up the tree and don't stop till you find the first theme or block provider you run into. It's just a locator. That's all it is. Now, understanding all this isn't just theory for a tech interview. This has real, practical consequences for your app's performance. When you know the rules of the game, you can build much, much faster apps. To get that silky smooth 60 frames per second experience that users expect, you have about 16 milliseconds to do everything for a single frame. That's it, 16 thousandths of a second.
Every inefficient operation, every unnecessary rebuild, it all eats into that tiny budget and causes that jank and stutter that we all hate.
Now, this is a really, really important distinction to make. A rebuild is not the same thing as a repaint. A rebuild is when your build method runs. That costs CPU time to create all those Dart objects and do the comparisons. A repaint is when the pixels on the screen are actually redrawn. That costs GPU time. The key here is that a rebuild does not always cause a repaint. If the new widget has the same configuration, Flutter is smart enough to just stop and not do the expensive GPU work at all.
But there's a hidden villain in this story, the garbage collector. Even if you aren't repainting, rebuilding widgets still creates a ton of little short-lived Dart objects. And that puts pressure on the GC. If the garbage collector has to kick in and run in the middle of your 16-millisecond frame budget, it steals precious CPU time away from your app. And that right there is often the source of that mysterious jank. The takeaway? Avoid unnecessary rebuilds.
All right, we have gone deep. Let's pull it all back together into a clean, concise summary. This is the answer you give when someone asks you how Flutter really works under the hood.
It all starts here. Flutter's UI architecture is built on a separation of concerns across 3 distinct layers: widgets, elements, and render objects. First up, you have widgets. Remember, they're just the blueprints. They're cheap, they're immutable, and they're totally disposable.
Then you have the elements. They are the persistent construction managers. They're the living instances that bring those blueprints to life, hold on to state, and manage the whole life cycle.
And finally, the render objects. They do all the expensive, heavy lifting of layout and actually painting pixels to the screen. So when you call state set, the whole system kicks into gear. The cheap widget blueprints get recreated, the persistent element managers compare the new blueprints to the old ones, and then they intelligently command only the necessary render objects to update. That is the secret to Flutter's incredible performance. So you're in on the secret now. You're not just telling Flutter what to build, you understand how it thinks about building it. The real question is, with this new mental model, how is that going to change the way you write your code?